on the same one?
Yeah, it's 1.2.
I'm sorry. Oh, because I have to stop it.
Yeah,
I didn't
stop
realize
the
it was
poll.
a poll.
Yeah.
And then docs.
No, that's right. So if you just click on
Oh, 1.2.
1.2, yeah.
So send this one out.
Mm-hmm.
Okay. Oh, well, this would make a lot more sense. Okay, so go ahead and do this one, and this will bring us back to that little AC method that I was talking about. So remember, guys, this one you can either look at the chalkboard for some instructions, or if you just need to remind yourself about a step, but you should also have this in your notes. So, you should also have some other problems we've done like this before. Right, Jaquan?
What?
Is this the last spelling in the shipping? So this will go into this primary structure? Okay. So remember, we're looking for two things that multiply to A times C, and those factors also add up to B. Okay, does that work? Okay, but also remember, think about the positives and the negatives of those two.
Exactly. I know this. Oh, this might just be 8. Not -2, just -8.
Alright guys, let me get you back up here. So this, we were given this quadratic equation in the standard form, and so it wants it in factored form. This one is a perfect one to use that AC method for. So when I say the AC method, Caleb, what am I looking for?
He was out all last week for
My
surgery.
Preston.
Yeah,
What?
Preston doesn't have that excuse.
What was the question?
So what am I talking about when I say this AC method? What does A and C refer to?
The A and C. A times C.
A times C from here, right?
Yeah.
So my A is 1 and my C would be what?
12.
Okay, so I'm looking for factors of 12 that add up to B. Well, what is B?
-8.
Okay, everybody in here, notice right now that my B is -8. Okay, so you're thinking, how is that going to work? If I have to add two and I have two numbers that add to be negative, but they multiply to be positive. Right there, you know that both of your factors are going to be what?
Negative.
Okay, so we're looking for a combination of two negative factors that can multiply to this positive 12. Okay, so what did you guys come up with?
-6 and -2.
Okay, and do those add up to -8?
Yes.
Okay, so remember from here, so I saw some people factor by grouping, and some people just went ahead and kind of did the shortcut way because our A value is just 1 here. Or remember, when we factor by grouping, we have to split up this middle term. Because factoring, remember, we're essentially working backwards from that distribution. So to get this B, we had to combine something first. Well, those two things we had to combine, we found out what they were. So we can expand that middle term to represent that. So a lot of you guys, I saw it maybe you're right here. Okay, so now from here what you do, remember, you have to factor one of those groups at a time. Okay? So, Keyshawn, looking at this first group, what can I factor out? An X, right? So then what would that leave me with on the inside? Okay? X minus 2. Now remember, so I have an X minus 2 on the inside of the parentheses over here. I want to have the same thing over here. So, what can I factor out of this second group? Anybody? Okay, I can take out a 6. Well, that's going to leave, oops, sorry, you want to keep that sign. Keep that sign. What's that going to give me, or what do I need to put on the inside so that when I multiply it back out, I get a 6x plus 12? Okay, does everybody see that? Okay, so from here, since I have 2 of them that match, that's one of my factors, and then my other factor comes from what's left. Okay, so this is something we maybe got stuck on doing this morning. I hope this kind of reviewed it for you, but we're going to go back into practicing some of these now. Does anybody have any questions about this method, the AC method? It's okay. Remember, so when we have a value of A that's not 1, you have to pay a little bit closer attention to what factors you're looking for. So let's go into this 5.1. Remember, we looked at this example on Friday, or whatever, Thursday, whenever we were here last, and it showed us that you can calculate the roots for a quadratic equation. Well, remember, what was the first thing it did to that? It was equal to -3, but it didn't want it to be equal to -3, so what did it do? It added 3 so it could set the whole thing equal to what? 0. Guys, remember, if you have to set it equal to 0 before you can factor it, so it can be like this. And also remember we're using the zero product property to find what those zeros are when we're actually solving it. So we did a lot of practicing factoring on Friday on the TI Inspires where we sent out those questions. So now go back in your books to this 5.1 number 3. We have 4 problems. Oh, also go ahead and change. We're going to change this one to, let me see what I wrote. 2x. So on C, change the problem to 2x squared minus 6x equals 0. Okay, so guys, so this is, you're using factoring to solve each quadratic equation. Okay, so what we mean by this is, can you look at this, like number A, can you look at x squared minus 8x plus 12 and tell me what value we could substitute in for x to make that equation true? Like just looking at it, do you know what the answer is? Okay, so that means we can't solve quadratic equations when they're in standard form. So that's why we're factoring them. And then remember, when we use the zero product property to set them equal to 0, that's solving them. Okay? So standard, you can't solve them quadratics like that. We have to factor them first. So looking at A and B, do these look similar to ones we've looked at already? What's different between A and B? Right, so B is not equal to 0. So what do you think you're going to have to do before you can attempt to factor this quadratic? Okay, you're going to have to add 7 to make it equal to 0. So you have something that's in the form ax squared plus bx plus c equals 0. Once it looks like this, which you might even write this down, right, that you have to put something like this and then you can start factoring it. Okay, you can't forget we have to set it equal to 0 because we can't factor, or we can't solve the quadratic this in standard form. So, Mr. Finney, what did you just, the thing says solve it if possible. Did you say anything about the if possible part? Okay. Okay, guys, so on that, let's go. I'm going to let you work in your groups. Go ahead and start working on A and B. And if you can finish those, keep going. But we'll come back as a class and discuss those too. But yeah.
Did you emphasize why? Because this is the point that you made to me on Thursday, making sure they understand that it's an equivalent form, not completely different. You know what I'm talking about?
Oh, yes. Okay. Oh, because if we could graph them.
That idea, the standard form and the factored form, remember he told me we need to emphasize that
Yeah,
they're not completely different.
Okay, guys, so I'm saying when we can't solve it from the standard form, we put it in the factored form to solve it. But remember, if we were to graph that standard form and then graph this factored form, what would it look like on the calculator? On the graphing calculator? It would overlap. It would be parabolas. They'd do the exact same thing because the factored form and the standard form are equivalent forms of that quadratic equation, but in terms of being able to solve for our x's, we have to go to factored form. Okay, so we're using different techniques to view these quadratic functions in different ways. Does that make sense? Okay, y'all go ahead and start working on A and B. You get to C, start working on it, but we'll kind of come back together and make sure we're good there. Jaquan, wake up, we're doing math.
You know you always fidget you are.
Let's talk about it.
Mommy, stop. You're sitting right in front of me. Well, I'm sorry.
I've already added 7 on the
Miss Courtney.
Wait, Mr. Kenny, why you gave him the same one for the other?
So that they were already halfway there.
Okay.
It was intentional.
Was I not supposed to finish it in the bell ringer?
No, I mean, the factor, cause
We already
remember,
factored it.
okay, yeah, remember the,
Wait. Y'all keep working, hold on.
So the
This is
bell-
my,
the bell ringer was just the factor form. Remember,
I'll
we
go
wanna
get you
emphasize
one.
that. We
Nice.
want
So
that
now it's
primary
ready to
form.
solve.
Right,
Okay.
cause it's the emphasis on the zero product property at that point.
Okay, so I didn't realize that A was just going That's,
So
that would
they should
have
already
helped
have
them.
that factor.
Cause I already told them, I was like, okay, so now from here, you would use the zero product. Not realizing, okay, we factored
And
it,
that's
now
totally
we're.
fine, because I know like what I'm partially that.
But we gotta
To remind
solve
them
the
like, okay,
quadratic
this factor
equation,
form, okay, so when you have.
which is, cause it's
Was it
equal to zero.
off the equal zero? Because they were just used to factoring.
So we
Yeah.
like,
This is now.
distribute it out.
That we're solving, remember, I think the whole thing about it is you're solving. Okay, so if you have to solve for something, you have to set it equal something.
Yeah.
So it would be
And
x
that was another
squared.
thing, is like, I even had them tell me to use the inverses to start solving it from standard. Pointed out like, okay, we can't do that. But we have this factor, it is hard to solve it, and that factor.
That's what we just got.
I see.
Regarding properties and.
That's just the
Well, I did run into
Oh,
the
then I think
thing
it
you
was
showed D.
combined like term.
I think it's two.
That was.
I was like,
Negative 6 minus 2 is
sometimes I just
negative
can't
8.
look at your paper and I was like, oh.
Yeah, yeah, that's the whole point.
I was like, tell you you're giving me something you're supposed
Yeah,
to do.
And I would bring them back together pretty quick on this one.
I'm trying to
Okay.
get back to that.
Well, I will because I didn't realize they are this.
So minus
Yeah, there's like a
2 is 12.
Okay, so I really like how a lot of y'all are using the expos on the desk to like write out your ideas and manipulate some of these values, but always remember to transfer that work back onto your paper. Because that's what you'll be able to look at when you're not at school and you won't remember what you wrote on the desk. Yeah.
What'd you say?
Yes, keep them set equal to 0 and then never use the zero product property to solve for. So the same thing we've been doing, except now we're kind of looking at it a different way.
Don't you like x squared minus 8? That's a square.
Okay guys, so remember this is telling you to solve each quadratic equation. So that means after you factor it and say, okay, these are the factors, what does it mean to actually solve it? What are we looking for? When we're solving a quadratic equation, what are we looking for?
Zero.
We look for zeros, right? So do you guys remember how to solve for zeros?
Yes. Yes.
Okay, so don't just stop when you're done factoring it, you have to solve it. Okay, so go ahead, keep going.
I think I square rooted it too early. To where I messed it up probably. Or I didn't. Or I did that wrong. I could have done a lot of things wrong.
We're here to learn. We can learn.
Oh, why's your 8x on this one?
I can't help it.
Did you move it over? You cannot squeeze that. I'm sorry. I'm on my bed.
So, no, that'll be a minus. You're right, that'll be a minus there. So what's the minus in between the 7? Because it's negative 7x, so that'll be negative 7x.
It should be. Let's find out.
So, what you wanna recognize at that point
It's either gonna be a plus or a minus, so you have to just keep the same one as already in the middle.
But I don't know if that's right.
is the idea that you're gonna have.
It's not, is it?
So
Miss Courtney,
that middle.
Yes, ma'am.
You wanna rewrite.
we don't think we did this right.
Factors. So there's your 7x.
I don't know.
Okay, look, so look, we did all this junk.
Was.
What was that equal to 0? Well, now, how do you find zeros once you know it's in factored form?
Really, nothing? So it means that you're gonna use it.
That's all we have to do.
There's no way.
We did all this exercise.
About to solve the quadratic equation.
So you knew and you didn't say anything?
Okay,
I'm
I
over
didn't,
here.
I didn't know that.
okay, so you know it's x minus 2 and x minus 6 are in factored, right? So continue to
No, you silly yourself.
set it equal to 0, but when we say
Oh,
solve,
that's
look for
I'm
zeros.
sorry.
So you have to
I know I did this zero. I didn't know what I was doing. I was just trying.
when you solve it, you get x equals 2 and x equals 6. That's what we mean by, we're gonna solve this quadratic equation. You gotta factor it and then solve it. Can't do that.
It was all during the fall.
It was already right.
Okay. Hold on, we're gonna come up here for a second. I see you everyone's struggling right now. So, this was our warm-up problem, so is everybody okay if I just go ahead and write, the factors we found for it? Okay, everybody's good up to this point? Okay. So in our warm-up, it told us to factor the expression. So that's what we get from here. In this problem, we have to solve the quadratic equation. Notice how the standard form is equal to 0. So remember how I said standard and factors, those are equivalent forms of that expression? So I still go ahead and need to equal that to 0. Okay, because continue to equal it to 0 because we're solving for something that's missing, right? That's what we mean when we say solve. Okay, so from here, if I were to say, let's look back think back to our previous unit. If you were at this point and we said, okay, find the zeros of this quadratic function, what would you do?
Set the factors equal to 0.
Set each factor equal to 0. Because what does the zero product property say?
At least one factor gotta be 0.
That one of those, if A times B equal to 0, then either A or B equals 0. Okay, so that's what we're doing here. It's showing that we're applying the zero product property. Okay, so now from here, Tamia, what would you do to solve for this x? Okay, so we would use the additive inverse to, I'm going to rewrite that C on the bottom. So that x equals 2, and then, Wynesia, what do I need to do right here to solve for x? I just need to add 6 to both sides. That creates that 0, and I'm left with x equals 6. So the solutions to this quadratic equation would be x equals 2 and x equals 6. What would it look like, what would those x equals 2 and x equals 6, what importance does that have on a graph? Those are the x-intercepts, those are the zeros, that's where my parabola is crossing. So guys, remember all this stuff is still connecting, okay? So, where y'all at on this one? You found your factors and you're trying to solve them? Okay, I'll give you about a minute and a half to continue on B and then we'll come up all back together.
Okay.
I'm coming. You have a question? Okay, I'm coming. Alright.
No, because I thought you were like equal it to 0.
Yes.
When you like carry this to the other side, because it was plus 7. Or did I take it to the other side? So it should be 0. Or am I wrong? I would like. Oh yeah.
So
Okay,
we
never
talked
mind.
about today,
I got it right.
how could we?
Do you want a cookie?
Yep.
Sorry, but then, I do also get free.
I said equal to 0, get the factors out of it.
And if you want me to, I can talk through this square, and then you talk through the completely square theory. Or if you feel ready to talk about it.
What did I just write?
Like this example that I have drawn up.
I wrote this so wrong.
On the chalkboard.
Do you want to? Okay.
Where your mind is, my boy.
Oh, is it gonna be next?
Not supposed to.
Okay, let me get y'all back up here. So, Jesus, what's the first thing you have to do in B? Why did you have to add 7 in B? Because I'm creating 0, but why do I have to set this whole thing equal to 0? What am I trying to do here? I'm trying to factor it. I'll show that plus 7 up here. Okay, so,
I
question.
put the 7.
What method did you guys use to factor this one? AC method, that works. So our A times C equals what? 7. What are the only, 7's a prime number, right? So aren't prime numbers really easy to use when we're factoring? Okay, because the only factors are 1 and 7. So we can split this middle term up to say plus x plus 7x plus 7 equals 0. Okay, so then from here, Jakeem, what was your question you had for me earlier? Was it something like this? So what do I need to do now to start factoring?
You can find things that you said, right?
Well, I've already found that 1 and 7 multiply to 7 and add up to 8, and I've split it up. So I can group these two things. But what do I do after I group them, guys? What am I looking for? I'm looking for a GCF, okay? KT, what's the GCF in this first group?
What?
A little bit more specific for me?
1x?
1x. Good, so I can factor out a 1x, which would leave me an x on the inside. To get that x times x would give me that x squared. So then, what do I need to add to it? Just 1. Okay? The sign. Okay, over here, guys, what can I factor out of the second group?
7.
7. And then, what's that going to leave me on the inside? X plus 1. If you weren't sure, did you have a hint of what it should look like?
Yeah.
Okay, notice how the whole way down, I'm still setting these things equal to 0. The whole way down. Okay, so from here, which I'm going to come right on the side now. Are we done? I factored it. I got to find the zeros. Actually, I have to actually solve this quadratic equation. And that's what we mean by when we say you're finding the zeros, because you're solving it. So we can rewrite this in the factored form. Because remember, when I have 2 of the same factors on the inside parentheses, that's one factor, and then the x plus 7 is what's left. Okay, so then when you set both of these equal to 0, what do you guys get?
You get x equals -1.
Okay, you get x equals -1 and x equals -7. Okay, so now we say these are the solutions to this quadratic equation. Okay, so remember, what does it mean if it's a solution? It makes that equation true. Okay, so those solutions would make this equation true. Okay, have y'all done C yet? Sorry, let me rewrite what it is. 2x squared minus 6x equals 0. Not this fraction thing that even kind of scares me a little bit. So, have y'all gotten this one yet? Okay. This one's also very similar to the warm-up. So, Xavier, what would you suggest I do first over here? Find the GCF. So, what would the GCF be?
2x.
Okay, so I do have a 2, but also notice, guys, I have that x. Good job. So, once I factor out the 2x, everything that I need to put back in is what's going to multiply out to my original equation. Okay?
Thank you.
Oh, go ahead. Okay, so that would be x minus 3. Okay, so what if I wasn't sure if I factored this thing correctly? What if I wasn't sure that 2x times x minus 3 really equaled that? What can I do? Multiply it back out. 2x times x is what? And then 2x times negative 3 is, okay, so check yourself. Okay, then, so then from here, are we done? Well, I'm not done, Tyrese.
You gotta find the zero.
I gotta find the zeros. How am I gonna do that? What do I do from here? Okay, so we can set 2x equal to 0, and then x minus 3 equal to 0. So from there, what two zeros do you find? Okay, so to solve for this x, we have to divide by 2. So what's 0 divided by 2?
0.
Okay, so we have zeros at 0 and 3. What's up, Caleb? Okay. Does anybody have questions about A, B, C? Are y'all so comfortable with this that y'all are bored with me talking about it?
Yep.
It's okay. That'd be great, honestly, if you get it. Okay, let's look at D. Have y'all looked at D yet? Okay, take a minute, look at D, and let's try to factor it. If you've already looked at it, just hang tight for a minute, okay? We'll talk about it in about a minute. Take about a minute in your group to start thinking about how can we factor D so that we can solve it.
Wait, leave that up there. Let me see, write it.
Miss Courtney,
Yes,
can I see what?
okay.
2x. I'm sorry, it's so horrible.
So when it don't equal, what is that?
So when it doesn't equal 0? Oh,
Because I
like
erased
this
mine, thanks.
Okay, so like with this one, you would have to set it equal to 0.
Don't do me
With
like
this
that.
one, let me ask how to explain that.
Oh.
Mr. King,
Okay, I'm done.
This is a really good question.
You did
So
one
you see
for
how, well, yeah, but you see how C and A, they're set equal to 0. Or even they set equal to 0. D is set equal to f of x.
Right.
Why?
So
What's the
it's
difference?
a true function, and so what I told them is, I'm asking you to solve it, I'm
Why
asking
does
you
it
to
not have
find
an
the
X?
zeros for
Oh,
it.
dang.
So essentially, okay, so, okay.
And I think I had that conversation before, at least, so if you wanna bring it back, all have that discussion, that would be valuable.
Okay, so who's saying that
Equal A.
No.
this is like the function,
Yeah.
so to solve for it, you would set that equal to 0.
This is